Good morning, everyone. Welcome to our last week of school. Today we are going to start by looking at sine, cosine, and tangent, and I love this concept. This is a concept that you guys will use in algebra. It's a concept that you will use in FST. In fact, it is the very foundation of trigonometry. Now, I'm going to leave those uses for your later teachers, but what we're going to look at today is how to use sine, cosine, and tangent. Now, before we do, there's one thing that you should always do right as soon as you see sine, cosine, and tangent, and that's to make sure that your calculator is in the correct mode. And for us, we're using degrees because we're talking about the degree measure of an angle. Now, in order to switch to the correct mode, go to the button next to the second that's labeled mode, and use your arrows to move down to where it says radian and degree. Switch it over to degree, or if it's like mine and it's already in degree, you can exit out. So you want it on degree, and once it is, just press second, quit. And that will bring you out, and your calculator's now in the correct mode. In fact, you can quick just double check. Just to explain the difference between these are like feet versus inches. Feet versus like centimeters. They're two different units of measurement for how to measure an angle. Radian we tend to measure circular things with, or curved things, and degrees we tend to use to measure things like angles in a triangle. So right now we're going to be using degree for sine, cosine, and tangent. In later years you might use radian, but for now just always make sure as soon as you see sine, cosine, and tangent you are in degrees. I'd hate for all your answers to be wrong because you just switched that. So let's set aside the calculator and talk about sine, cosine, and tangent. Now, what these are just stored proportions in your calculator. So if I were to type in the sine, this button right here, the sine, cosine, tangent, of something like 52, I'm going to get an answer that's a decimal. This is just a proportion. I could also do something like the tangent of 32, and that gives me another decimal answer. And that's because sine, cosine, and tangent are just proportions. In fact, it turns out that right triangles have proportional sides to each other. And the sine, cosine, and tangent are just going to explain what proportion you have depending on the angle given to you. So, what we're going to talk about to describe sine, cosine, and tangent are the relationships between the three other sides. And in order to talk about those three other sides, we're going to need to label them. Now, the first side that you should always label when you see a right triangle is the hypotenuse. That's the side that is opposite of the right angle. No matter what angle you're given, the hypotenuse will always remain exactly the same. So I could give you this for your angle, which we tend to call theta, right? Or I could give you this for your angle, or theta. Doesn't matter. In this case, we're just going to focus on the one down here. Now the other two sides will flip-flop in their labels depending on whether I give you this angle or this angle. But we're going to call one the opposite side, and that's just the side that is exactly across from your given angle. And we're going to have the adjacent, which is the non-hypotenuse side that is attached to your given angle. So again, notice how these would flip-flop if I gave you the other angle. So if instead of my triangle the way I had given it to you before, I gave you this one, the opposite side would now be here. The adjacent side would be here, and the hypotenuse will remain unchanged. So the hypotenuse will always be the same, but the O and A might flip-flop depending on what angle is given to you. Okay, so why do we need to know these O's, these A's, and these H's? Well, because sine, cosine, and tangent are just the proportions in a right triangle, the sine of theta describes the relationship between the opposite side and the hypotenuse. So sine is equal to opposite divided by the hypotenuse. That's how they get that. And the cosine is going to be the adjacent over the hypotenuse. Adjacent over the hypotenuse. And their tangent is going to be the opposite over adjacent. So those are the three relationships between the sides. The order does matter here. And there's a nice way to remember these, okay? And that is the SOHCAHTOA. Say it to yourself about like 3 times out loud. Be a little ridiculous. If you can memorize this, you've memorized these formulas. Because this is saying so, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So just by remembering SOHCAHTOA, you actually have memorized 3 formulas. SOHCAHTOA, sine, cosine, tangent. Okay, so let's try some of these formulas out. Now, I know I said trying these formulas out, but what do I mean by formula? Well, if I'm given a triangle like this, where I want to find one side, I want to find this side up here, x. I only know one side in an angle. Well, what I do know is that these 2 sides are proportional to each other because it's a right triangle, and they're proportional to each other according to this angle. All I need to do is go back up to my formulas and figure out which one of them best matches it. Is it the sine, cosine, or tangent that will show me the correct proportion between these 2? All I need to do to find out that is determine what sides are given to me. So I'm going to label all of these as adjacent, hypotenuse, or opposite. Well, I know that the hypotenuse is the one I should start with. And the hypotenuse is 17. It's opposite the right angle. And the side that I'm looking for, is opposite my given angle. So that means that in this one, I have an O, or I have an H, and I want an O according to this angle 59. Well, which of my relationships have an O and H? Well, that's SO, or sine. And I know that sine of my angle is going to be equal to O over H. So I use my O and H to say which of my functions. I write it out, and now I can substitute in what I know. Well, I know that my theta is my angle. So what I'm saying here is my sine of 59 is going to be equal to the relationship between the 2 sides. And I want my O, which I don't know yet, that's just x, over my 17, or my H value. Now I can actually solve because I only have one unknown variable. And this is where your calculator comes in handy. I can actually find the sine of 59. The sine of 59 is just a number. It's a proportion that is stored in your calculator. The sine of 59 is 0.85716, so on and so forth. So all I need to do is replace the sine of 59 with that number. And drop that into your formula. So I've replaced this whole thing, this whole proportion, with the number that it represents. And now I can solve for x, multiply both sides by 17 to get an answer of x is equal to 14.572. And that would be your answer. This side would be 14.572. Now we can do this with all of our various sides. So if I'm given this one for number 15, where I have 27 as my angle given, I have a hypotenuse, the side opposite the right angle, given, and I have the side that's attached to my given angle, or adjacent side, as well. Here, I don't even need to worry about this opposite side. Since it's not listed or anything's asked about it, I don't need to label it at all. So what I'm going to do is I'm going to figure out what function relates the A and the H, and that is the cosine. The cosine of an angle is equal to the A over the H. So all I need to do is fill in everything now that I know which function I'm using. Cosine of my theta, or 27, the degree, is equal to adjacent, my unknown thing, divided by my hypotenuse, or 20. Here, if I want x by itself, I can multiply both sides by 20. So I have 20 times the cosine of 27. Now, I could have found the cosine of 27 first, but it's kind of nice to just be able to type that whole thing into my calculator rather than end up with this messy decimal. So I'm going to do that. I'm going to do 20 times my cosine, again, that middle button's over here, cosine of 27. And that gives me an answer of 17.82. And so that's my final answer. Now, last but not least, I think I just made that messier. Last but not least, I have one other example to give you, and that is number 17, which has, again, a right triangle, so I could use SOHCAHTOA. And in this, I have 40 degrees as my angle. I have an x and I have a 20. Now notice that here my hypotenuse, the side opposite the right angle, is not labeled at all. So I don't even need to label the hypotenuse over here. What I do have is a side that's opposite my 40 degrees, and I have a side that's adjacent to my 40 degrees. Since I have O and A, what I'm looking at is TOA, OA, or tangent. So the tangent of theta is going to be equal to my O over my A. Let's fill that in. So tangent of 40 is equal to 20 over A. 20 opposite A, x. Now, when I do this, there's a slight problem here that I have an x here that is in the bottom. I'm going to have to multiply both sides first by x to get the x out of the denominator. I can't just divide by 20 because 20 here is not doing the division, okay? Is being divided by. So if I multiply both sides by x, I end up with x times the tangent of 40 is equal to 20. That's great because I no longer have a variable in the denominator where it's trapped. Here, divide both sides by the tangent of 40, and you end up with x is equal to 20 over the tangent of 40. And 20 divided by the tangent of 40 will give me my final answer. So I just type that into my calculator, press enter, and I have an answer of x is equal to 23.835. And that would be my final answer. Now this can happen where the x is in the bottom with sine, cosine, or tangent. It's not just going to happen with tangent, okay? So just watch out that if the x is in the bottom that you start by multiplying by x and then divide by the tangent. Really, if you want to know, there's always going to be a shortcut where you can swap whatever's in the denominator with whatever's on this side. Like these two things will just swap over. So this x is now in the place of tangent and tangent's now in the place of x. That will work as long as it's this initial setup, okay? So you can use that shortcut, or you can just remember, just multiply by x to get it out of the denominator first. What I want you guys to do is try out sine, cosine, and tangent with 14, 16, and 18. All I need to see is your answer in the comment section. Okay, your answer in the comment section. And that's the personal comments, not the ones to the whole class, please. So find those 14, 16, and 18. Tell me what x equals for each of those. I hope you guys have a wonderful day. I will see you guys all tomorrow with some more practice with sine, cosine, and tangent.